Hema Cholen, welcoming you to EPG Pathshala. Now I will be presenting on the topic Digital Preservation Part 2, wherein Part 1 module has been already discussed separately. Let us see some of the objectives to be discussed in this module. Digital preservation metadata, models and standards, major functions of preservation programs, and storage management of digital preservation, microfilming, a hybrid solution for digital preservation process, and major digital preservation programs initiatives in India and worldwide. Now let us see the introduction part. Preservation metadata is one of the vital building blocks in the digital preservation programs. Without preservation metadata, digital material will be lost. Preservation metadata provides the vital information which will make digital objects self-documenting across time. This part of the module provides an overview of preservation metadata, metadata models, standards and functions of digital preservation programs, and this module also discusses patterns of storage management and microfilming as a hybrid model being practiced for long-term preservation. The module outlines selected worldwide and Indian initiatives towards digital preservation programs. What is digital preservation metadata? It provides structured ways to describe and record information needed to manage the preservation of digital resources. It is one of the vital building blocks in the digital preservation programs and essential in order to establish and document the authenticity, integrity, provenance and trustworthiness of digital objects. Effective digital preservation depends on a set of preservation services such as conserving materials, digitizing collections, preserving library content in the digital formats, and providing robust education and outreach programs that needs digital preservation metadata to work together to ensure that digital objects are preserved for long term. Three types of digital preservation metadata are the OAIS model, that is Open Archival Information System. This OAIS reference model was developed by NASA's Consultative Committee for Space Data Systems as the conceptual framework describing the archival systems for the long-term preservation of digital data. This OAIS has been now been adopted as an ISO standard. The model establishes the terminology and concepts relevant to digital archiving and processes and information. A model consists of the three components for digital objects and their associated metadata. So, Open Archival Information System has three metadata, that is submission information package, that SIP is the content and associated metadata ingested into the repository at the time of deposit, and archival information package AIP is the content and associated metadata actually stored and managed by the repository over the long term, and dissemination information package, that is GIP, is the content and associated metadata provided by the repository in response to access request by the users. The metadata in OAIS model plays an essential role in preserving digital content and supporting its use over the long time. The OAIS information model implicitly establishes the link between metadata and digital preservation, that is preservation metadata. The OAIS reference model provides a high-level overview of the types of information needed to support digital preservation that can broadly be grouped under description information and representation and descriptive information. Let's see about preservation description information. The preservation description information consists of four major types of metadata elements. First is reference information, which is used for identification or description and includes global identifiers local to the archive, and some method of pointing to an existing descriptive metadata record for the resource such that it can be referred to unambiguously both internally and externally to the archive. For example, ISBN and URN. Next is the provenance information. It documents the history of the content information, example, its origins, chain of custody, preservation actions, effects and rights management, and helps to support claims of authenticity and integrity. The next is the context information, which documents the relationship of the content information to its environment, how it is related to other object, how it is related to other manifestations of the same object, and how it is intellectually related to other objects. For example, why it was created, relationships to other content information. The next is the fixity information. Documents authentication mechanisms used to ensure that the content information has not been altered in an undocumented or unauthorized manner. Example, checksum or digital signature. Representation and descriptive information. Representation information facilitates proper rendering, understanding and interpretation of a digital object's content. At the most fundamental level, representation information imparts meaning to an object's bit stream. For example, it may indicate that a sequence of bits represents text encoded as ASCII characters, and furthermore that the text is in French. The depth of the representation information required depends on the designated community for whom the content is intended. Descriptive information metadata contains more ephemeral metadata, the information used to aid searching, ordering and retrieval of the objects. So now let us discuss about the premise, preservation metadata, that is implementation strategies. In 2003, OCLC and RLG established preservation metadata, that is implementation strategies, premise, an international working group composed of more than 30 international experts in preservation metadata. Premise sought to define a core set of implementable, broadly applicable preservation metadata elements supported by a data dictionary, and identify and evaluate alternative strategies for encoding, storing, managing and exchanging preservation metadata in digital archiving systems. In September 2004, Premise released a survey report describing current practice and emerging trends associated with the management and use of preservation metadata to support repository functions and policies. The final report of the Premise working group was released in May 2005. The Premise Data Dictionary is a comprehensive practical resource for implementing preservation metadata in digital archiving systems. It defines implementable core preservation metadata along with guidelines and recommendations for management and use. Premise also developed a set of XML schema to support use of the data dictionary by institutions managing and exchanging premise conformant preservation metadata. The premise data model consisting of 5 entities associated with the digital preservation process, that is intellectual entity, a coherent set of content that is described as a unit, example a book, and object, a discrete unit of information in digital form, that is a PDF file, and event, a preservation action, example ingest of the PDF file into the repository. Agent, a person, organization or software program associated with an event, example the publisher of the PDF file who deposits it in the repository. And rights, one or more permissions pertaining to an object, example permission to make copies of the PDF file for preservation purposes. Each entity is described by a set of properties called semantic units. Each semantic unit represents a discrete piece of information to be recorded as part of the metadata supporting the digital preservation process. In short, a premise semantic unit can be recorded in any way a repository finds convenient, given the processes and architecture of its repository system as well as its metadata management procedures. A semantic unit can be recorded as a single metadata element or broken up over multiple metadata elements if the repository prefers. METS, a standard for packaging metadata and content together in digital repository system. METS, that is metadata encoding and transmission standard, is designed to organize and link different types of metadata to its associated content in the OAIS reference model. METS is an XML schema designed specifically as an overall framework within which all the metadata associated with a digital object can be stored. A METS file comprises of the 4 major constituent sections. A file inventory for all the files associated with the digital object, including still image files, text, video or audio files. A section for administrative metadata, a section for descriptive metadata, and a structural map which indicates in a hierarchical manner how the various components of the item relate to each other, so allowing its constituent elements to be navigated by the user. These 4 sections are linked to each other by means of identifiers. The practical implementation of the METS can be very flexible as well. Any system capable of handling XML documents can be used to create, store and deliver METS based metadata, and METS provides the ability to associate a digital object with behaviors or services. Now let's see some of the major functions of preservation programs. The UNESCO's guidelines for the preservation of digital heritage describes the following functions that a full-fledged digital preservation program should perform. The creation of a safe place. That is, preservation programs must identify or create a safe place for storing and managing digital materials. Organizations may either set up its own infrastructure or outsource its digital preservation activity to a reliable third party. However, it is the responsibility of the concerned organization to ensure long-term availability of their digital contents. The process of loading a digital file into a digital repository along with its descriptive metadata for subsequent retrieval is referred to as an ingest. The steps involved in ingest include applying collection policies and selection criteria to ascertain whether material can be accepted on submission or not, checking the quality of the material submitted, including its completeness, authenticity, and ascertain that the material has duly been scanned for viruses, and also assigning unique identifiers to digital objects, assigning and managing copyright of digital material, assessing the elements that must be maintained and assigning preservation objectives, setting retention and review periods for the digital material as deemed appropriate, checking and upgrading the documentation that describes the material including the technical and preservation metadata, checking the file formats and converting them into another format if so desired to comply with the policy of digital preservation program, and also saving digital objects and associated metadata after verification to the archival storage system. Now let us see about the archival storage. A digital preservation program should provide archival storage that maintains, protects and verifies the integrity of the stored digital objects and associated metadata, whether stored as a single data stream or as separate but linked data streams. The archival storage system must include practices to ensure protection of data stream from unintended change, damage or loss which can be achieved by regular copying of the data stream to fresh media or to new media types when necessary. Storage practices should also include regular checks such as checking of data stream against corruption, then system security, backup regimes that place copies at remote sites, and disaster recovery plans that address contingencies such as complete loss of the system's operating infrastructure. Let us see about the preservation planning now. The basic function of preservation planning is to monitor threats to accessibility to digital material and to specify action required to counter such threats. While archival storage offers data protection, its continuing access has to be ensured. The technology changes that affect accessibility should be monitored. The remedial action may involve migrating or upgrading of the digital objects into different format or encoding or changing the metadata that describes the means of access and links to current access tools. Now let us see about the implementing preservation strategy. Preservation strategies discussed earlier differ substantially in their method of preserving digital records. However, the process of implementation is quite similar. Steps involved in implementing preservation strategies adopted by the National Archives of Australia are that is identify materials required preservation, research appropriate preservation strategy, test proposed solution, backup records identified for preservation, apply the preservation treatment, audit the integrity of preserved records, destroy source records where appropriate, and establish monitoring regimes. Now let us see about data management. Managing digital materials in the archive generates its own data about what material is stored, what can be accessed, and about the management of the archive. This data must be managed to support use of the archive and to support its effective administration. Now let us see about the access. This function provides a user interface to the archive, allowing users to browse, search, and discover its holdings, to request for material and receive its copies. Access to archives may either be restricted or it may be made available to all potential users. The access function may well require mechanisms to control access. License and advocacy. The preservation program and libraries must advocate good practices among producers of digital contents with an aim to facilitate long-term availability of the material for which the program will be responsible. There is also a need to understand who would be the likely users of the material, so that preservation and access arrangements can be tailored to their needs and expectations. Let us see now management, administration, and support functions. A digital preservation program must be managed professionally. It involves development of policy frameworks and standards covering all areas of operations, the ongoing supply of appropriate resources and infrastructure, including suitable technical systems, and in part management processes such as monitoring and reporting on the program's operations. The OAIS reference model is a high-level conceptual framework that can be used as a reference point for those designing, using, and evaluating real implementations. Now let's see storage management for digital preservation. One of the crucial threats to digital preservation is short life of storage media, obsolete hardware and software, and slower read times of old media. The selection and installation of software components are crucial while building digital preservation program. The basic tenets of digital preservation extend much beyond storage media life. Devices used for reading storage media rapidly become obsolete. Various formats and the changing versions of digital documents and images introduce additional complications. The storage operation in digital archives primarily address to the media level formatting of information objects. Primary considerations for storage of digital materials include levels of hierarchy and redundancy. A digital archive may have multiple levels of storage depending upon the levels of expected use and expected retrieval performance. Digital repositories that are too large to store on a single disk can use hierarchical storage mechanism. In an HSM, the most frequently used data is kept on fast disk, while less frequently used data is kept in near line, such as an automated robotic tape library. An HSM can automatically migrate data from tape to disk and vice versa as required. Digital material in a distributed network may be stored online in multiple locations. Besides offline and online storage, nearline storage may be adopted, wherein information objects may be stored on optical or tape media and loaded in a jukebox. Retrieval time in nearline storage systems is higher in comparison to online storage, but is considerably more responsive to user demand than offline storage. A digital archive may use any or all of these methods. The most sophisticated systems combine the resources so that objects in use or recent use are stored online, and they age from the time of the most recent use. They move to near line storage and then eventually to offline storage. Redundancy is another important storage consideration. Effective storage management thus means providing for redundant copies of the archived objects to ensure availability of documents in case of loss. A number of RAID, that is redundant array of inexpensive disk models, are now available for greater security and performance. The RAID technology distributes the data across a number of disks in a way that even if one or more disks fail, the system would still function while the failed component is replaced. Digital archives may also choose to make backup copies on their own or to make arrangements for other sites to serve as backup. Although hard disk, that is fixed and removable solutions, are increasingly available at an affordable cost, optical storage devices including worm, CDR, then CD-ROM, DVD-ROM or optomagnetic devices in standalone or networked mode are attractive alternatives for long-term storage of digital information. Optical drives record information by writing data onto the disk with a laser beam. The media offer enormous storage capabilities. Some of the important features of storage infrastructure for satisfying requirements of digital preservation are increased scalability, wherein the storage media should be scalable depending on the requirement of a digital archive. Availability of storage devices to multiple servers, that is, the storage system should be a shareable device that can be accessible from multiple servers. Increased availability and sharing among storage devices allows for effective load balancing and redundancy. Intelligent storage networks and network attached storage are now available, in which the physical storage devices are intelligently controlled and made available to a number of servers. High speed throughput, wherein the storage device should utilize fiber channels for carrying traffic between devices at high speed. Separation from the LAN, that is, the storage system attached to a digital repository should not only be accessible via devices physically connected to it, or so that the storage system remains unaffected by traffic on the user LAN and vice versa. Now let's see about microfilming and digital preservation, a hybrid solution. Microfilming is a tried and tested technology for preservation of documents with proven longevity. The life expectancy of microfilm is in the 500 plus year range. In 1992, renowned microfilm expert Don Willis drew upon developments in the infant technology of mass digital storage to suggest the possibility that microfilm and digital technologies could be combined to meet the needs of both archival storage and digital access. The proposed hybrid solution suggests microfilming of document as first step and then digitized from the film master. It is argued that for a computer image to match the resolution of higher resolution microfilm, the item would need to be scanned at over 600 dots per inch, which is practically impossible with prevailing scanning technology, as it would require incredible scanning time and storage space. Moreover, neither the scanners are designed to scan as such a high resolution, nor the documents scanned as such a high resolution can be displayed using present day display technology. The hybrid solution provides the best of both worlds. The high resolution microfilm masters can be safely archived and retrieved when needed to generate new high use, highly accessible digital version. The process also serves to circumvent the problems with digital technology, that is constant migration. The life expectancy of microfilm is in the 500 plus year range. The microfilm master, if properly stored, is quite simply the most stable reformatting method available today. Yale's Open Book project suggests that in preservation microfilm that produces better quality digital image products, but that the cost incurred in creating such film will not be recouped through reduced digital conversion costs. Let us see major digital preservation programs. The first one is, let us see about the Portico's digital preservation services. Portico is the largest community supported digital archives in the world, which is committed to the preservation of digital publications such as e-journals, e-books and other digital content. Portico is collaboratively working with the libraries, publishers and funders to ensure researchers and students who will have access to it in the future. Portico offers the easiest way to ensure that the digital content is kept safe. The various approaches of Portico are it preserves the largest and broadest collection of e-books and e-journals of any third-party preservation archive, and it maintains legal agreements with publishers to guarantee long-term preservation. It monitors and communicates information about the abandonment of journal and e-book titles. It helps set industry standards and utilizes best practices for e-content validation and authentication and metadata management and also distributed replication. Portico preserves the content through a format-based migration strategy. The key points of this strategy are identifying key preservation metadata at the initial point of preservation and practical preservation of content such that the content is only migrated at the point where it becomes necessary. To meet the goals of digital preservation, that is usability, authenticity, discoverability and accessibility, Portico follows exact standards and processes for content management and maintenance and replication of the archive, content cell checks and third-party archive certifications to ensure quality and security, and maintain a delivery system and services to provide access to users in ways that are as easy and integrated with other online resources as users expect. The second program, let us discuss about the locks, that is lots of copies keep stuff safe. Locks program based at Stanford University Libraries provides libraries and publishers with award-winning, low-cost, open-source digital preservation tools to preserve and provide access to persistent and authoritative digital content. The only approach that mitigates against the broad set of technical, economic and social threats to the security and long-term preservation of digital content. Locks award-winning open source technology is built on a peer-to-peer software infrastructure that preserves trustworthy, authoritative and original scholarly content for long-term access. It is a cooperative, affordable and decentralized preservation system over a shared library network that relies on lots of copies to keep stuff safe. Locks technology preserves the publisher's original content as of the date of web publication. The look and feel of the content along with the publisher's branding is preserved, resulting in an authentic representation of the authoritative source file. The locks program also preserves the likes going into and out of digital content, links that reference other digital objects and provide valuable context to the original work. The locks approach takes steps to ensure libraries are responsible not only for short-term access but involved in at many stages in the emerging model of journal archiving. Now let us discuss about another program, that is the clocks, controlled clocks, which is a not-for-profit joint venture between the world's leading academic publishers and research libraries, whose mission is to build a sustainable, geographically distributed dark archive with which to ensure the long-term survival of web-based scholarly publications for the benefit of the greater globe research community. Built on low-cost, open-source, award-winning locks technology, the clocks archive comprises a network of redundant nodes located at 12 major research libraries into which e-content is ingested, copied and preserved. Clocks decentralized, geographically disparate preservation model ensures that the digital assets of the community will survive intact. Clocks is committed to provide very long-term preservation solution. It aims to become a safe haven for scholarly content from all corners of the world, including underserved scholarly communities and those who cannot afford to archive their materials on their own. Now let us see digital preservation initiatives taken in India. Center of Excellence for Digital Preservation is the project under the National Digital Preservation Program of the Department of Electronics and Information Technology, Government of India. This project is designed and maintained by CDAC, Pune, India. Objectives of this project are as follows, that is it conducts research and development in digital preservation to produce the required tools, technologies, guidelines and best practices. And also it develops the pilot digital preservation repositories and provide help in nurturing the network of trustworthy digital repositories, that is National Digital Preservation Infrastructure, as a long-term goal. It defines the digital preservation standards by involving the experts from stakeholders, organizations, consolidate and disseminate the digital preservation best practices generated through various projects under a National Digital Preservation Program, being the nodal point for Pan-India digital preservation initiatives. Also, it provides inputs to Department of Electronics and Information Technology in the formation of National Digital Preservation Policy and strategy by identifying and selecting the activities for the National Digital Preservation Program. Also, it spreads awareness about the potential threats and risks due to digital obsolescence and the digital preservation best practices. So that's all. Now let us summarize what we have discussed in part 2 of digital preservation. In this module, we discussed about various metadata specifications like premise or METS, and have the status of de facto standards with well-defined community processes for maintaining and updating digital assets for long-term preservation, while the Open Archival Information System OAIS reference model defines a framework with a common vocabulary and provides a functional and information model for the preservation community. The METS schema provides a flexible mechanism for encoding descriptive, administrative and structural metadata for a digital library object and for expressing the complex links between these various forms of metadata. The major functions of a preservation programs governed by UNESCO's guidelines for the preservation of digital heritage, and how effective storage management is possible through media level formatting of information objects are well discussed in this module. Other selected digital preservation programs in India and also discussed worldwide and also discussed about the initiatives taken in India also. So that is all. Thank you.